In this video, we are going to look at mass, weight, and also look at the differences between mass and weight, and also some examples, calculations that involves mass and weight. So let's begin by mass. Okay, so now we can begin by defining what mass is. So mass is defined as the amount of matter in an object. So we can just say total amount of matter. So the material, the material that is found in an object. Now, apart from knowing the definition for mass also, we can look at the measurement for mass. Would find that mass can be measured in grams, or it can be measured in kilograms. Then also it can be measured in tons. So all these are measurements or units of mass. But among these units of mass, the SI units of mass are kg or kilograms. Now, from there, we need to know the instrument that we can use, or that is used when we are trying to measure a mass. So mass is measured by an instrument known as a beam balance. So a beam balance. Then apart from knowing the instrument, you need to know that mass is a scalar quantity. So in terms of quantities, mass is a scalar quantity because mass only shows the magnitude. There is no direction. If we say a sack of millimil has a mass of 25 kg, we are just talking about the quantity. We are not adding the direction. We can't say it has a mass of 5 kg east or west. That can't make sense. So mass is a scalar quantity because it only shows the magnitude. Now, apart from knowing the grams, the beam balance, then the other thing that we should know, mass is constant. Mass is constant. So if we have a bag of a millimil on Earth, if we have 25 kg on Earth, even if we go to the moon, the mass will still be 25 kg. So the mass is constant. So these are also but these can also be the differences between mass and weight. Sometimes you may have a question where you're asked to give maybe 2 or 3 or 4 differences between mass and weight. Now let's look at weight. So weight is just the force. So weight is just the gravitational force that the Earth exerts on an object. So we are saying the gravitational force. So it's a gravitational force that the Earth exerts on an object. Then number 2, weight. Weight is measured in newtons. And the symbol for newtons is capital letter N. Then in terms of measurement, weight can be measured by a spring balance. So we have a spring balance. Then for quantity, weight is a vector quantity. So weight is a vector quantity. So this is a vector. So here we are expecting to have both magnitude and direction. So let's say if we have this is the Earth or the ground. and we have an object that is moving in this direction. So we can see that the heaviness of this particular, let's say if we can say it has 2 newtons, so this 2 newtons, that is its magnitude, because this tells us the heaviness, how heavy this object is. Now this object will move in this direction, so we have the direction. The direction is this object will move toward the earth. That's why we said it is a vector quantity. Now weight is not constant, so weight varies. It varies because of gravity. We can see that the gravity on Earth is about 9.8. If we round it off, we can see that the gravitational force on Earth is 10 newtons per kg, but on Moon we have about 1.6 gravity. So you can see that the gravity on Moon is less than the gravity on Earth. So we are expecting weight to differ, because weight comes in when we multiply mass times gravity. Let's say if the formula for weight is equal to mass multiplied by gravitational force, which is weight is equal to mg. So let's say if we have like 25 kg of minimum, if we want to find the weight of this particular bag on Earth, we'll say weight is equal to, where there's m, we put 25 kg times the gravity, we use 10 newtons per kg. So this and this cancels. 25 times 10, we have 250 newtons. Now for the weight, if we are trying to find the weight now on Moon, we can see that the mass will still be 25, because we said mass will not change, but this time the gravity is 1.6, approximately 1.6. So 25 times 1.6, 25 times 1.6, we have about 40. So you can see that the two weights are different. On the Moon we have about 40, but on Earth we have about 250. So we can see that weight changes, and the reason why weight is not constant, because the gravity is different. Then the other thing, the relationship between mass and weight. The relationship between mass and weight is given by this formula. Weight is equal to mass multiplied by gravity. So if we want to find weight, we need to multiply mass and the gravity. But if we want mass, if we make mass the subject of the formula, we are going to have weight divided by gravity. So that's why we are saying that we can see that mass is directly proportional to weight. If we increase mass, weight also increases, but mass is inversely proportional to gravity. Okay, so let's look at what we are saying. Let's have so what we are saying is, we are saying weight, mass, the relationship between weight and mass. Weight is directly proportional to mass. Okay, provided that the gravity stays the same. Let's say we have gravity on Earth, we say we use 10. Now let's say the first mass we use the 10 kg. Then the second mass, we have 2, we have changed from 10, let's say we have 15 kg. So let's calculate the first weight. So mass is 10 kg times our gravity, which is 10 newtons per kg. So here we can see that we are going to have 100 newtons. Let's calculate the weight now using the other mass. So our mass this time is 15 kg times our gravity. We are saying this remains the same. So we can see that 15 times 10 is 150 newtons. So we can now conclude that if we have weight and mass, if the mass increases, the weight also increases. That is what it means by a direct relationship. If one factor increases, the other factor also increases. Now let's look at if we are now solving for mass. So we said mass is equal to weight over gravity. So let's look at the relationship between mass and gravity. So since we are looking at the relationship between mass and gravity, we'll consider weight to be constant. So let's say we have an object with weight of, let's say, 100 newtons, not 1000. Then we'll say the first we are going to calculate in terms of gravity. So what we are going to do is, let's say we are going to have gravity of 10 newtons per kg. Then in the other gravity, let's say we use 20 newtons per kg. So let's calculate the first mass. So if the weight is 100 newtons and the gravity is 10 newtons per kg, we can see that 10 into 100 is 10 kg. So we are able to get 10 kg. Now let's find if we change gravity to 20. So where there is weight, we are saying we are assuming weight to be constant. So weight is equal to 100 newtons over 20 newtons per kg. So we can cancel the newtons. So 20 into 100 is 5. So it's 5 newtons. So you can see that when gravity was 10, the mass is 10 kg. Now when gravity was 20, when gravity increased from 10 to 20, the mass reduced from 10 kg to 5 kg. So we can see that the relationship between mass and gravity, the relationships, they are inversely proportional. So what this means is, if the gravity increases, the mass decreases. So that is what it means by inversely proportional. Okay, now let's maybe have some examples that we can calculate from this. Okay, let's say we have an example of calculate the mass of an object. Not mass, let's first begin with weight. Let's calculate weight of an object that has a mass of 20 kg on Earth. Then B, we can say an object that has 300 grams on Moon. So since we have some basics in mind, you can try to pause the video and give it a try. Okay, so now we know that the formula for weight is equal to mass multiplied by gravity. So the mass here, we can see that we have 20 kg. Then on Earth, we said we can just use 10 newtons per kg. So you can see that this kg and this kg cancels. So 20 multiplied by 10, we have 200 newtons as our weight. So we can see that the calculation of weight involving mass is very simple. You just multiply the mass times the gravity. Now let's look at for this one. So mass times gravity. Now we know that gravity on moon is about 1.6. So this is not the exact number. This is not the exact number. So here what we are going to do is, let's look at mass. Now this time the mass is given in grams. So remember, at the beginning of this I said the SI unit for mass is kg. So if you are given mass in grams, remember to convert that mass into kg. So we are going to use 1 kg. So 1 kg is equal to 1000 grams. So we know that kg means kilograms. So the word kilo means 1000. So 1 kilo, like 1 kilometer, that is 1000 meters makes 1 kilometer. 1000 grams makes 1 kg. 1000 kilowatts makes 1000 watts. So whenever you see a kilo, that means there is 1000 of whatever that comes. So kilogram, 1000 grams, kilometer, 1000 meters, kilowatts, 1000 watts, kilohertz, 1000 hertz. So we can now proceed by finding the mass in kg. So our 300, so I'm just trying to show the working here. So the 300, since it's in grams, the 300 grams will be written where the grams are. So here we put x, then we cross multiply. So 1000 grams times x is 1000x. Then here we have 300 kg. So we divide by 1000 grams over here by 1000 grams. So x is equal to 0.3 kg. So the concept here is, if you have mass in grams and you are trying to convert into kg, you divide a given number by 1000. But this whole thing, I just wanted you to know how we show, if you want to show the workings. So in a simpler way, we can say 1 kg is equal to 1000 grams. Then if we are converting from kg to grams, you multiply by 1000. But if you are converting from grams to kg, you divide by 1000. That's the easiest way. So let's now proceed. Our mass is now 0.3 kg times our gravity on moon is 1.6 newtons per kg. So we can cancel. So 0.3 times 1.6. So what you can just do is, if you are dealing with calculations like this, then you don't have a calculator, you can ignore the decimal points. So if we ignore if we ignore the decimal from 1.6, we have 16. Then if we ignore the point from 0.3, we have 3. So 16 times 3, that is 48. So 3 times 6, that is 18. We have 1. 3 times 1 is 3 plus 1, that is 48. So now, after we have this 48, we are going to count the total number of decimal places that we have. So from the 1.6, we have 1 decimal place plus another. So we have 2 decimal places in total. So we are going to move 2 times. So we have 1, 2. So the decimal comes here. So the answer is 0.48 Newton. So this is how you can answer a question like this. So I'm sure we at least have some ideas on how we can calculate weight on Earth and on moon given the mass. So that's it for this video. Thanks for watching.